Yeah, this is 1.6, yes. So, like I said before, there's two ways, right? We're gonna stretch things vertically, or we can stretch things horizontally, and I'm gonna explain both and show you an example of both. So let's begin by talking about how to stretch something vertically, okay? So, if I give you any function whatsoever, like any f of x function that I gave you the other day, it could be the square root function, it could be the cubing function, it could be the absolute value function, any of those functions that I give you, okay? We can stretch them out, or we can shrink them down vertically, okay? And so if I give you any old generic function f of x, and I take this number c, and if c is bigger than 1, so like 5, 6, 7, 8, 9, 10, any of these numbers are bigger than 1, and we multiply this number by our function, then we get what's known as a vertical stretch, okay? We get a vertical stretch if we are taking any value that's bigger than 1 and multiplying it by our function. Notice where the c is. The c is on the outside of our function value, all right? Now, if we take our c value, let's say the number's between 0 and 1, like 1/2 or 2/3 or 1/8, okay? If we take that number and multiply it by our function, then we end up getting a vertical shrink, okay? So these are the two options that we have for vertical stretches, up or down, right? I'm talking about stretching or shrinking, okay? So here's an example on the right-hand side, and I'm going to give you a full-blown one that we'll do together, right? But this kind of like illustrates what's going on. So do you see this function here, the square root function? That's my blue function over here on the right-hand side, right? I have it just graphed like it normally would. That's the parent function. So we have 0, 0, we have 1, 1, we have 4, 2, the regular old blue function. Cool with that? Yeah. Okay. Now, check this out. I've written this, y equals c times the square root of x. And this is going to be the red function. It's kind of behind this blue function. You can't see it yet because right now c is set to a value of 1. Alright? But watch what happens. So see this c here and this c over here match. Do you guys get it? Do you see where it is? So what's going to happen then if I take the value of c and I can move the value of c around whatever I want, if I make it bigger than 1, what should we expect to see? We should expect to see a vertical stretch, and we're going to compare it to the original parent graph, which is the blue one. So here's the deal, right? If I take this and I move this to bigger than 1, watch what happens to the graph. And look, it's been pulled up. So that's a vertical stretch. It's like someone takes your graph and pulls it straight up for you, okay? So how do we get these values out? Well, that's what this red part over here says. You multiply the y coordinate by c. So to get these actual stretched values, you would multiply all y coordinates by whatever number you're multiplying the function by. All right, and we will do an example by hand together. The computer is illustrating what's happening in real time. All right? Now let's say my c value is in between 0 and 1. So what's in between 0 and 1, you guys? Like 1/2. Yeah, so let's move the c value in between 0 and 1, like 1/2, like right about there, okay? Use non-discrete value, so let's go there. So notice that, check it out, my red graph now has been vertically shrunk down. So the original one is the blue one, that one stays there, and notice the c value is in between 0 and 1, it's 0.56. So therefore I'd expect a vertical shrink, and that's what it looks like over here. Is that making sense to you guys? Hello? Yeah? Did you guys see what's going on? So if I go past 1, right, then I get a vertical stretch. If I go in between 0 and 1, I get a vertical shrink. And then, of course, if it's at 1, well, then it'd just be the normal graph anyways, right? One the one we started with. What would happen if I went negative? What would I get? I get a reflection. Yeah, very good. So if I go to the negative side, so if I go below 0, but stay between 0 and -1, I'll use non-discrete values. See, look what I get. I get a reflection and a shrink. See that? So it works in negative land as well. Okay, that's vertical. So everything in the green box is what you'd want. Let's talk about horizontal now. Okay, again, everything in the green box is what you'd want. So, I have a feeling that my Oh, okay, so let's do this one then. Let's talk about horizontal stretches and shrinks, okay? So, again, it's the same kind of setup here. If I have a c value that's greater than 1, and I take my function, but notice where the c is. Where is it on the inside? Oh, shoot. Where is it compared to the other one? Dang, I just get it right. It's on the inside, right? It's on the inside here, so I totally get this way. So the difference between a horizontal and a vertical stretch is where that value of c happens to be. So this one's on the inside, okay? So if my value of c is bigger than 1, I'm going to get a horizontal shrink, which means it's like someone's taking my graph from the horizontal, from the left and right, and squishing it together, okay? Now, what if my c value is in between 0 and 1? Well, that would be a horizontal stretch. It's like someone taking it and pulling it apart left and right, okay? So for this example, what I've done is I've given you a different one. I've given you the absolute value function, right? And again, this c matches, oh shoot, that's supposed to be on the inside, huh? So here we go. Let's do it there. Oh, gnarly. Is that gonna work? There we go. Okay, good. There we go. All right, good. So they're both on the page now. So check this out. If I'm going to move my c value to a value that's bigger than 1, we would expect to see a horizontal shrink. Okay, so if I move my c value to a value that's bigger than 1, so check it out. It's like someone took my graph and put it together and shrunk it this way, horizontally. Does that make sense? Okay. Then what if I go in between 0 and 1? What do I expect to see? Yeah, so if I go over here between 0 and 1, kind of like that, it goes a little bit wider than the original graph. Does that make sense? Okay, so how do we get these coordinates? Well, we're going to divide x coordinate by c, and that's the part that we're going to need in just a second, okay? All right, so is the concept sinking in? So there's two ways we can stretch things, right? Vertically or horizontally, and it's either going to be a stretch or a shrink for both cases. Good? Okay, here's what I want you to do now. I want you to draw this picture onto the coordinate plane. And so call this box 3, all right? Draw this picture. And I'll pause this. So here is the deal. I have this function here, and this function is in red. All right, passes the vertical line test, so I have some function here, and I have 4 points on the function. I'm going to create 2 more graphs on the same exact coordinate plane that you see here. I'm going to create a blue graph and a green graph. The blue graph is going to be 2 times the function. The green graph is going to be f of 2x. Do you see the difference? Okay. So this one, my blue function here, because the 2's on the outside there, is that going to be a horizontal stretch or a vertical stretch or shrink? Yeah, okay, so go back to your notes, right? If you didn't know, this is going to be a vertical stretch because the c value is what in this case? It's a value of 2. And what are we going to do? We're going to multiply every y coordinate by that c value, okay? So we'll go back to our graph here. So I'm going to do 2 times f of x. So we are going to, again, if you didn't catch that, we're going to multiply the y coordinate by that c value. So instead of -4, -2, what's the y coordinate? I'm going to multiply that by what? By 2. So I'm going to have -4, -4. Do you see how I did that there? Okay. Now, instead of -1, 2, what's the y coordinate? We're going to have -1, 4. Exactly. Instead of 2, 0, well, the y coordinate is 0, and 2 times 0 is still 0. So actually, that point stays there. And instead of 5, 2, if we multiply the y coordinate, we're going to get 5, 4. Okay. And then when you connect that graph, ladies and gentlemen, that is a vertical stretch by a factor of 2. Do you see what's going on here? Now, what if I gave you, instead of the number 2 on the outside of that function, what if I gave you a 1/2 on the outside of the function? What would that have done to it instead? That would have been a vertical shrink. That would have been a vertical shrink. But you would still calculate it the same way. You would multiply the y coordinate by your c value. Okay, now how is this different than my green graph here, which I'm going to do for you, which is this one? Notice where the 2 is. This is a horizontal shrink or stretch. So this one is this one. It's a horizontal shrink because the c value is 2. It's bigger than 1. So it's going to be a shrink, and we divide the x coordinate by c. You guys catching on?
Yeah.
Good. We divide x coordinate by c. So go over here. Instead of -4, -2, what's the x coordinate? And we're going to divide that by, so instead I'm going to have -2, -2. You see that? Okay. Instead of -1, 2, the x coordinate is -1. Let's divide that by my value of c, which is 2. So what would it be? -1/2, comma 2. Okay, instead of 2, 0, the x coordinate is 2. We're going to divide that by 2 because that's what my c value is. So what would that be? That'd be 1, comma 0. Notice I'm not doing anything to the y coordinates on this one, right? And then lastly, instead of 5, 2, we're going to divide the x coordinate by half. What would we get? 2.5, comma 2. So check this out. If you compare the green graph to the original pink graph, that's a horizontal shrink. So someone like took our graph and like compressed it inwards towards each other. So do you see the difference between them? All right, that's what you need to be able to do.